So here is the problem that we had talked about in class that we didn't have time to do today. Problem number 35 from section 7.4. And this is a partial fraction decomposition problem. And one of the issues that we have to deal with is the ability to be able to factor this. It's not something that we can usually do, so what I'm doing is I'm using techniques from college algebra, which is to use synthetic division. First, I noticed that if I plug in 1 for x, I get 1 cubed minus 1 squared plus 4 minus 4, which is equal to 0, and that implies right away that x minus 1 is equal to a factor. I perform synthetic division, and what this is the x squared term, this is the x term, this is the constant term, and that's the remainder, which means that this is actually equal to x squared plus 4. So there is no middle term for it. And x squared plus 4 is an irreducible quadratic, which means when I do partial fraction decomposition on it, I'm going to end up with my a over x minus 1 and then my bx plus c over x squared plus 4. And I'll let you look through this and work it on your own. This is just the work to end up finding that a is equal to a fifth. I found c was equal to 4/5, and I found that b was equal to 4/5 as well. But the real reason that I wanted to put this on here was to talk about how to do the integral. The integral ends up being split up, and this one's easy. That's just a natural log because it's 1/5 times the integral of 1 over x minus 1 dx. This is the one that we want to talk about. And before, what we tried to do is we tried to force the numerator piece of it to be equal to the derivative of the denominator. But in this case, I'm noticing something. I'm noticing that if I split it up into two integrals, so here's my integral, the x plus 1, and end up splitting it up so that I have an x over x squared plus 4 and a 1 plus x squared over 4, that I can do each of these separately. So this one here, this is a u substitution where I let u be equal to x squared plus 4. Follow it through and you'll get an answer of 2/5 natural log of x squared plus 4. This one is a trig substitution where x is equal to 2 tangent theta. Follow that through and you'll get a 2/5 inverse tangent of x over 2. So this was the reason that I wanted to show this one. It's not about forcing the numerator to be equal to the derivative of the denominator. It's about recognizing that I can actually split it up and work with it that way. And this is the final answer for it. So if you have any questions, do let me know.